Hello and welcome to this video. In this video we are going to look at several topics. We are going to look at functions, their arguments, how and what are the calling conventions followed by functions, and we are going to introduce you to a wonderful concept of pointers, which is very interesting. And then we are going to look at function calls. So functions. We have used functions in our previous lectures, like printf is a function, scanf is a function. In mathematics, sine is a function, cosine is a function. So what we can infer is that a function performs some task. And one thing is that when you need printf, you should call it. You should write printf. So it needs to be called. Any function, if you want to make use of its services, you have to call that function. For example, main is a function, right? Main is a function. Main is called by the operating system. So this is what a function is. Now you can have user-defined functions. User-defined functions, these are your functions. These are the functions of the programmer, and the most important thing here is that you have to decide them. You have to define them. Right? Your functions, you define them. Functions provided by the C library, C defines it. The creators of the C language defined it. So your function have to be defined by you. You have to define that. Right. Okay, for simplicity purposes, let's write our own function. Like main is a function, you can write your own functions. So let's have a function called printline. Printline function does nothing but prints a line. We will print a line in this function. So we have the function printline, similar to what main is. Main and printline. Okay. And the body of printline, similar to main, and we can have any statements. Let's have a printf statement that prints a line. So printf, and let's print a line here, dash, and at last \n, so that it goes to the next line. So we have printed a line. Now we are not returning anything from this function. Like we don't return most of the times from the main function, hence we write void main. If had we returned integer from the main function, we had to write int main. So similarly, in this function we are not returning anything, so we have to write void before that function. So void printline. So this is our function. This is a user defined function. We have defined it. Printline cannot be understood by the C compiler, but we have to make it understand what printline is, and we have to tell it that this is my function, you have to execute it. Now we are going to write a program based on this function. We are using this function, we are defining it, declaring it, and using it. But before that, let us see what output we need. Let's say we need one line to be printed, and then the text written should be rock on. Just imagining now. So rock on, and then another line. So this is our output. So let's go to our compiler and write this program. So starting off with #include stdio.h, standard input output header. Then we have void main right? And in main, what we are doing is we are first printing a line, then printing rock on, then printing another line. So we have our function void print line. So first of all, define that function. You always have to define that function. So you cannot define any function inside a function. So you cannot define your function inside main. So you have to define it outside main. So you have your function void print line like this, and inside the body of your print line you had printf, and inside printf you had a lot of dashes. So it prints a line. It appears like a line. So this is a function. Let's use our function. How do you call printf? You write printf like this. How do you call your own function? You write your own function. So you are printing a line, then printing some text, right? You are printing some text. Let's put a new line here, and then you are printing another line. So this is how your program is. Let's see the output of this program. So it is showing error in our output. It is saying that print line identifier not found. Now I told you that you have to tell the compiler that print line is your function, because it does not know what print line is. It knows printf because printf is already defined in the C library. It is a standard library function. This is a user defined function. It does not know what print line is. So like you declare variables and then define it, that is initialize them. Similar is the case of functions. You have defined a function now. We have defined a function now. The only task remaining is to declare it. So how do you declare variables? You declare variables at top of the main, right? You declare variables here, and similar kind of lines you also have to declare your function. So declare your function outside, above main. So you declare it here. So your function prototype is void print line. So you have to tell your compiler that void print line is a function that returns nothing, that returns void, and this semicolon is necessary. So this is your declaration of a user defined function. This is the function you are calling. So, and this is your definition, what you are doing in this function. Now if I run this program, I think this will work correctly, and we did get the expected output. We expected this output, and indeed we got this output. So let us analyze this program. Okay, this part of your program, void print line and the semicolon, is called declaration, or it is called prototype. It is also called the prototype of your function. And when you write printf, you call printf actually. So on similar lines, when you write print line, you write the name of your user defined function. This is nothing but a function call. So this is a function call. And this definition is called definition. You're defining your function here. Okay, now let's try to determine how this program ran line by line. So first of all, it included standard input output header. Then it understood that yes, there is a function, user defined function print line, that returns nothing, that returns a void. And remember, this semicolon is very necessary. Then our main function got executed. Now as soon as it encounters print line, the control goes to the function print line. Now it jumps from this print line to this call print line to the actual definition of the println function, of your user defined function. It jumps to your function, executes your function, and then goes back to what, where you came from, goes back to main. Now the next line, the next statement will be executed. Printf will be executed, and then another print line. So printf is executed, this print line is executed. Now it comes here again, the same process is repeated. Print line is executed, and then you go back from here to here. Naturally the program ends here. So this way your program is executed if you have a user defined function. Now few things to be noted is the calling function and the called function. Let me write here calling function and the called function. Now you must have guessed correctly that the calling function, from where the call originates, is the main, because this call is originating from the context of main. So calling function is the main function. In this case you can have any, could be any function. You can call any function from any function. So in this case the calling function is main and the called function is println. You see, printf is also a called function here. So calling function and called function you need to remember. And you know this, but let us still again revise how the control goes. I mean, from where the control goes to where. So firstly the control is in main, then it goes to println, main to println, then it comes back to main. Whenever any function's execution is complete, your control comes back to main. Like when you go to printf, now printf's code must be somewhere in the C library. It is executed and you come back, the control comes back and executes other statements which are below. So println main and again println. This is with regard to our user defined function, not the printf. So and main. So this way the control flows back and forth in the calling and the call function. Now there are three things which are very important when you consider user defined functions. First is declaration, second is definition, and the third is function call. So let us look at how do you declare any user defined function. Let's take the example of a print line. You declare it by the return type first, void, and then you have the function name. So in this case our function name is print line, and this semicolon is very important in declaration because you're declaring. While defining, you give meaning to the function. So you have same void print line, and then you have statements inside it, any statement you want. And how do you initiate a function call is just about how you initiate printf. How do you call printf or scanf? Just write the name and pass the arguments. So in this case we don't have any arguments, so just write print line. Okay, now we come to a point where we can understand function arguments. Functions arguments. Now let us take the simple example of our function which we have used, scanf. Scanf, how do you write is, you write this format specifier. Let's take the format specifier as %i, which means integer, and it needs address, so address of num. Let's assume that num is a variable. So now the arguments are separated by the comma. This is one argument, this is another argument. These are arguments. Arguments, or you can call parameters. Many people call them parameters. So these are arguments, and parameters. Now let's say take the example of a user defined function. Let's say you have a function called named add. Now add, and you pass it two arguments, a and b. Now what add will do is, what you will do in add is to take a and b, add them, and return. This time return something, like we have said c equals to add a comma b. So add a comma b will return, and that will be assigned to c. So this is a function call, right? This is a function call, and whenever this add will be called, it will return something on doing some operation, and that returned value would be an integer, right? You will define it or you will declare such type of function. Okay, let's declare this add function. How do you declare a function? Is just write its return type. What are you expecting in return is an int, and the name of your add is of your function is add, and you need to accept something. Okay, first let us define that function. Okay, now this is the definition. You are returning an integer, and you have the name of your function as add, and you are accepting, accepting two integers, a and b. So you are accepting integers, so you should write int, maybe some x, and int y. And what you will do in this function is you will declare another integer z, and z is equals to x plus y, and return z. You will return the value of z. And inside the main function, what you will do is you'll do nothing but what you'll do is c is equals to add a and b. Let's write the whole program at once now. Okay, what I've written is I've declared three integers a, b, and c. We are taking input a and b. We have to add a plus b and store it into c. So for addition, we have created another function add, which is a user defined function. We pass it a and b, like we pass printf, the format specifiers, and the list of variables. To add, we are passing the list of variables a and b to be added. So in add, I collect a and b as x and y, and I add x and y and return the value which I have added, that I have stored in z, to when the function returns, when the control returns. And this return value gets stored in c, and we are printing this c. What we have been missing is the function prototype, or the function declaration of this add. So on similar way, we declare it like this: int add. What we are accepting as arguments, as parameters, are integers. So we are telling that we are accepting two integers, so int and int. Although we can write the names of our parameters, but I think it's not recommended, because maybe you can write it, but most of the times I don't write it. So int add int int, it tells the compiler that there is a function, user defined function named add. It takes int as argument, it takes int as arguments and returns an integer. Okay, let us analyze this program. This is prototype, as we know, prototype, and this is a function call. Yes, we have learned this before, just a while. And this is the return type of this function, int, and these are the types of arguments which will tell the compiler what are the types of arguments that will this add function accept. Now one of the most important things here is that within the function call, what we are passing, a and b. what we are passing are known as actual arguments. We are passing, what we pass are called as actual arguments, and the arguments in which we collect are known as formal arguments. So in the function definition we have formal arguments, and in the function call we have actual arguments. This is just a terminology, you must remember it. And one thing you must remember is that variables which you use in the function add or in your user defined functions cannot be used in main, because whenever the function returns, whenever the control returns from your function, all the variables which have been allocated memory, which have been defined, declared, all get lost, or all die when the control comes back to your calling function. So all these are temporary, so you cannot access like x and y, you cannot access x and y here. On the same lines, when you leave the main function and come to your user defined function, although your main function variables do not die, you cannot access them. So a, b or c are not allowed to be accessed in your user defined function. You can have a and b instead of x and y, but these a and b will be different than the variables declared and defined in the main or from the calling function, because the scope is limited to this block, to this function. Main scope is limited to mains block. The penultimate thing that is remaining is this return statement. When you say return z, so the value of z is returned. So in place of add a comma b, z is there, the value of z, and that value is assigned to c. So return is nothing but it tells the control to immediately go back. Go back where? Go back to the calling function. Right. Go back to the calling function. Okay, and the most important thing here is that when the function call is made, add a comma b, the control goes to the function, and in the function you have to collect those actual arguments in formal arguments. So a gets copied into x and b gets copied into y. So actual gets copied into formal. That's it, you must remember for now. Okay, let us move on to calling conventions now. Calling convention of a function is nothing but a way of passing arguments. Sometimes you can pass the arguments from left to right, or sometimes you can pass the arguments from right to left. Now this convention of passing the arguments right to left, that is, first the rightmost argument is passed, then go on passing from right to left. Now this is called as the standard calling convention. This is the standard calling convention, and the C language uses the standard calling convention. It is by default activated. Let's say, let us take this example and try to solve it using the calling conventions right to left. We have int a equals to 1, then we have printf. We are printing three values: %d, %d, and the list of variables we are passing is a, plus a, and a++. Now it appears that if we go by left to right, it appears that the output must be 1 to 2. How 1 to 2? First, the leftmost A, let us take the value of A. A is currently 1. So A's value is 1. So first 1 is printed. Then plus plus A, pre-increment operator. First increment, then use. So first increment, A is 2. Then use. So A, then use means then print. So 2. Then post increment, first use, then increment. So first use, so 2, and then increment. So this. If you go by right to left, but this is wrong actually. This method we have used left to right is wrong, because C calling convention is standard calling convention, which is right to left. So always any function, the arguments are passed from right to left. So let's go by right to left. Currently the value of A is equal to I think, yes, is equal to 1. So first use, then increment. So first use, then increment. So this place is for this D. So first use, that is 1, and then increment. So A becomes 2. Now this is pre-increment. Rightmost operand done, rightmost parameter done, then we come to the middle one. So this is pre-increment. First increment, then use. So first increment 2 becomes 3, then use. So then here it is printed 3, and then this A 3. So this is the correct output. So you need to understand the calling convention. Okay, now we come to a point where we need to understand the topic known as pointers. Let us introduce you to the pointers. And pointers is one of the most interesting and one of the most challenging concepts of the C language. So let us start off by understanding pointers. So when we use the scanf function, remember we pass it the address of a variable. How do we get that address? If you remember, we get that address using the address of operator. This operator is known as the single ampersand is the address of operator. Right. What it does is gives address. Address of what? Address of variable. Right. Now consider this. Consider the statement int a equals to 5. Whenever the compiler encounters the statement int a is equal to 5, it does three things. Three things which are done are, the first thing is that it reserves memory space. Right? Whenever you declare a variable, you reserve memory space. Reserves memory space. Second thing that is done by the compiler is that you have reserved the memory space, now you name it. Remember first lecture or the second lecture we have done variables. We know that variables is like a box, like a memory space which has a name. So name that space. Name that space as, in this case, A. The third and the final thing it does is we have initialized also while declaring, so assign this value. Assign 5 to A. So let us draw the memory map. What is happening? So you know that memory is not a single cell, not a single space. It is divided into blocks. So there are a lot of spaces in memory. Spaces. This is how the memory looks. You have locations 1, 2, 3, 4, 5, starting from 0 to whatever the capacity of that memory is. So you have a lot of locations. So what you have done is you have reserved some memory space. Let us say our compiler reserves this memory space for us. and after reserving, it names it. It names it as A, and then assigns the 5 value to it. 5 assigning means it stores 5 in that memory location. Now you know that every memory location has an address. So all of these locations have address. So this also must have an address. Let us assume that this address may be 65,000. Right? This is the address. Or this can be also termed as the location number. Okay, now let us infer something from this information we have. When we say I, what we get is the value of I, that is 5. When we say address of I, what would we get? Right, the address of I, that is 65,000 in this case. Okay, now like the address of operator we also have a value at operator denoted by asterisk. Now asterisk is also multiplication, but it also performs the function of another operator. It is actually overloaded. It does 2 functions based on the context. One is multiplication, another is value at address. This is value at operator. It is also known as indirection operator. Indirection operator. This asterisk, it is kind of similar to address of operator. Address of operator gives address, and value at operator gives value at address. So if I say star of and of I, what would we get? We would get 5. If you don't understand this, let us put it this way. Value, this star means value, and address. This is value at address of I. In this we would get value at address of I is 65,000 in this case. So we would get value at 65,000 is nothing but 5. So we would get 5. So this way this operator works. AND operator means address of operator to get address of a variable, value at operator to get value at an address. Right? Value at an address. This is important. At address. Okay, now when I say address of A, it will yield 65,000, right? In this case. And what if I store this 65,000 into some other variable B? That means B is equals to AND A. If I do this, then let us visualize this. We have 5 in A and its address is 65,000, and we have some other variable named B, and we have stored 65,000 here, and B also has an address. So let us assume that this address is 20 maybe 532, right? Now this is value of B, because this is value of B, but this is also address of A, right? Now what I'm trying to show you is a pointer, actually, literally. This is address of B. Now let us put it this way. If I say star of AND of A, it would yield me 5. Value at address of A. Value at address of A is 5. What if I do star of B? What B contains is 65,000. It will become star of 65,000. Now what is value at 65,000? Which is nothing but 5. Now what I have shown you is actually a pointer. B is a pointer to A. Right? How? Why B is a pointer to A? Because B stores address of A. Because B stores address of A. Any pointer stores address of some other variable. You have to remember this, that if it's a pointer, it must be storing an address. Pointer is nothing but a normal variable which stores an address. That is, it points to some value at an address. It points to some value at an address. Now the question is, how do you declare a pointer? If I say, let me write all the declarations of pointers: int star x and char star y float star z. Okay, now let's review this. Int star x means that x is nothing but a pointer. Right? When you declare a pointer, you always use star before that. So pointer to an int. Now x is such a variable which stores the address of an integer. Similar is the case with y. It is a pointer to a char variable. Right? It stores address of some character. It is pointer to a float. Z is pointer to a float. Now considering this, if I say x is equals to and a, I declared int star x. That means x is a pointer to an integer, and in some part of a program I say x is and a. What this means is that x is a pointer to a, because x stores the address of a. Now what could be r? R is nothing but it has two stars, so it must be pointer to a pointer to an int. It must be a pointer to an int, right? So it is ptr to a ptr to an int. Let us put it this way. Let me write q is equals to address of p. That means q is a pointer to p. Then let me write r is equals to address of q. That means r is a pointer to q. Now in fact q is a pointer to p also, so r is a pointer to q, who is a pointer to p. That is, r is a pointer to a pointer, right? We can have pointers to pointers. That's it. Now let's move on to away from pointers, because it would take your head now. Let's move on to function calls. Do you recall in one of the previous lectures we had written a program of swapping the values of two variables? That means we had two variables, a and b. Now we had to exchange the values in between them. A's value goes into b and b's value comes into a. So we have to exchange the values of it. So for that we had written a program. Let's say we are making a function for the same program. Let's say we are calling that function as swap, S-W-A-P. Now we have to pass the values of a and b so as to swap them. So let us pass values of a and b as arguments. A and b are arguments. Now here we are passing values, right? And such type of call, when we pass values, is called a call by reference. It is called a call by value. Such type of call where you pass values to a function is called a call by value. On the other hand, if you write like this, swap and a and b, like you pass addresses and you manipulate those values using the indirection operator star, right? So when you pass addresses, such type of call when you pass addresses is called call by reference. You are not giving the value, you are giving the reference, you are giving the address. So from that address you can derive the value. So this call is called call by reference, and when you pass values it is called call by values. That's it we have in this lecture. We are done. Thank you for listening. Do send me your feedback and suggestions on this email address.